Hello and welcome to The Whole Package by Premier Packaging. I am your host, Billy Watkins, and today I have a pretty decent challenge before me of making 15 or 20 minutes talking about machine wrap. So let's get into this.
Yeah.
And thank God you're here with me. My guest today is Chuck Pomles, a man who knows a lot about
Stretch wrap.
Stretch wrap.
Yeah, as exciting or boring, depending on your perspective, that you think it is. If you're not in the distribution network or industry, you're going to be like, wow, that is really not interesting.
Well, but I'm just glad you're here to help me through this because, it'd be hard without you.
Yeah, no, it's an interesting process, and to be honest, the opportunities for cost savings and environmental impact are actually pretty great because of the plastics, and that's what stretch wrap is made from. The impact can be significant, so it's well worth talking about.
Kind of maybe an ugly thing, but it's a necessary thing.
Correct.
In distribution. You can't really get around it too much, right?
No, it is a topic from an environmental perspective. It is a topic that is very much what can we do differently to contain loads in transportation, whether it's air cargo, whether it's by truck or by rail or by sea, container. What can we do to contain them? And stretch wrap, when you look at the cost, even though it is stretch wrap, it's a plastic, for the alternatives that are currently available, and again, there's people working on it, it is the best option out there. And you need to stop the failures real quick, because if you have, you look at some of these sea containers coming over, if you have a load failure in a sea container or a load failure in a truck or something, that whole value of the truck could be lost because of the load failure. And then any other residual costs of cleanup or anything else that may happen. So when you look at it from that overall impact, stretch wrap is a very cost-effective approach for doing it. But again, it is an industry it's being very much worked on to try to solution it.
And something that Premier does, offers our customers and are darn good at doing, cut and weigh tests.
Correct. So cut and weigh testing of a stretch film on a load has multiple benefits. One, it can remove costs out of the product in the terms of the transportation network and the lane of that. Because all those costs get rolled into the cost of any product. The transportation costs are always rolled in. We can remove that. And then again, with the new technologies in plastics that are coming forward and in the films, some of the different characteristics of how the material is being used and how it's manufacturing, whether it's a cast or a blown film, can really impact, based on the load types, have huge environmental impacts. And the calculators we use, actually, for years, we have two calculators, one that just calculates purely costs. And over the past 6 years ago, we updated that to really start to calculate what's the environmental impact that it has. How many, trees are we saving? How many plastic bottles? How whatever the number you want to look at. What is the carbon impact of that? We're calculating that. And that's a huge impact when you're a corporation looking at how are we impacting the world in our operations and how can we improve that.
So it sounds like this can really help our customers, not just from, but most importantly, cost savings.
Correct.
Aspect of it.
Correct.
Kind of run me through exactly what we are doing with the cut and weigh test.
So what a cut and weigh test is we're going to gather a little bit of data beforehand. What does the load types you're packing out look like? Is it a nice uniform load of, let's say, beverage product going out on a pallet, or a cereal product going out, one product, same boxes going out on a load? Or is it a load of, let's think of a pallet going through the small parcel network? What does that look like in the distribution network where it's an irregular load? And you got different size boxes, different shape boxes, very inconsistent. It's not just this pretty little brick on a pallet. There's all sorts of indents. So depending on that, you have a couple different types of wraps you can do. But we come in, and we gather some of that data along with the weight of the loads, average weight, things like that. And we come in we start to make a predetermination of what films we would like to test based on this preliminary data that we gathered. Then we'll come to site with 2 to 4 typically, but we can do more if needed, different types of film to test on the customer's machinery. And what we'll do is we'll come in and the test will start off literally testing the force containment, meaning how much stretch wrap is needed. So the more uniform the load and the lighter weight the load, the lighter the stretch wrap can be. The heavier loads or more irregular loads tend to generally require heavier stretch wrap, but various other things that can apply in there. But the goal is to come in and use what's that force retention to hold that load so we don't have a failure in shipment of the load falling over in shipping. Then what will happen is after we get what is the current film on the line, we'll bring in some stretch film. You've got examples down there. We'll switch out the roll on the machine. Yeah, show the example, Billy.
There you go.
So there's an example of stretch film. We'll switch this out on the machine to test the different films and go from there. And again, run the same test high, middle, and low. We're not changing any of the wraps to start with or anything like that, or the machine wrap speed, and then come down and start testing that in terms of force calculation. But what we're doing is we're doing these multiple wraps is we're cutting off the film of each one. We will either weigh it right at the time or mark it and weigh it later, but we'll collect that film, weigh the film, and we're trying to get to less film being used in overall pounds, okay, or grams. We'll measure in grams, but the film is sold by the pound. So we'll take that and we'll do the calculations to work through that. So that's where the cut and weigh comes from, is you do all these force tests, then you cut the film off and weigh it to see what the potential savings are. And again, we have a couple calculators out there that we use. One, the original one we created was purely looking at costs, and again, about 6 years ago, we came back and started adding in a series of different environmental factors, and have expanded that over the years to really calculate also what's the environmental impact of that.
So now we have a little better understanding of what actually a cut and weigh test is. There's nothing like showing instead of telling. So let's head out to the warehouse and we'll perform a few of these tests and come back to discuss further. So stay tuned.
Awesome. Let's go.
Well, here we are, me and Chuck and I.
Yeah, Chuck and I.
On the floor of our distribution center. State-of-the-art distribution center here in Louisville, Kentucky. We're going to test out 3 different types of...
Well, we're going to test two of the 3 different styles of load containment gauges we have.
Okay.
And as we discussed upstairs, we've got a couple different ones. We have one that we made in-house, but we think these 2 are a little bit easier to use, so we tend to use these more than the ones we made in-house, but they're all pretty accurate. So the first one we're going to test, and I'm going to explain how the process is done, is made by Landtech, which is one of the largest stretch wrap manufacturers, packaging machinery manufacturers out here. Conveniently also right here in Louisville.
Right here in Louisville, yeah.
Yeah, so this one's a very simple, but what we're looking to do again, as we discussed, is we're looking to see how much force the stretch film is applying to the load to containment. So our example here is a bale of corrugated, and for the Landtech one, it's pretty easy to set up, but what you're going to do when we get to the highlight test gauge, which is literally just a round disc, you have placements, but you typically place at the top of the load, mid-load if it's a tall load, and down at the bottom. For this particular unit, we're just going to test the top and the bottom because we're a little bit of a shorter load overall. So for the Landtech, we'll start with this one. I prefer this one. It's quick, simple to use. We can get into customer sites, do the test very quickly, get off the floor very quickly, minimal interruption to production, right? So the tool is very simple to use. You simply space, using the wire, space out the gauge to where it should be. So now I'm simply going to space to there, and I'm going to simply take this hook, this pointed end right here, and stick it in between the film and the load.
Okay.
How easy is that to apply?
Pretty easy.
Pretty darn straightforward. Next, we're going to take our force gauge, and we'll hook it up to the test gauge. And this gauge works on a pivot, okay? It's a concentric gauge, so it's going to pivot around an axis. We simply come over here, hook our force gauge in, and we're looking through the side window to see when a red line becomes visible in the window, and I'm going to stop pulling. So I'm going to pull. There's the red line. There's the maximum right there. I got 14.8 pounds. Now,
you have to multiply it by 2, right?
yeah, we have to multiply it by 2 with this particular gauge because of the action, because of that cam action or that concentric action. I've got to pull it by 2. So we would record in our data in the calculator that we have. It helps calculate force loads, costs, and everything. We would record that information into that calculator. Then we would move on, simply remove the gauge and move it down further into the load. You see how easy that was to insert, and then move on to the next, gathering the next data. Same thing, pull, gather the data. We got 6.32, which converts to 12 pounds of force holding this on.
Does it make sense that it's less at the bottom than it is at the top?
It depends on how the machine is set.
Okay.
Okay. And for this one, we're looking at load stability overall. So we had a lot of wraps on the bottom, and then we put a few more wraps at the top, and you can kind of see we actually kind of missed the center load because all we're trying to do is retain this bale to the pallet.
Yeah.
But typically you do see a little bit less force on the bottom unless you put a lot more layers on. And considering we had 4 wraps at the top, 4 wraps at the bottom should be a little bit less. So that's using the Landtech. Going to the Highlight Industries one, this is where it gets a little more complicated. And do you have the tape measure?
I do.
Oh, perfect.
I'm ready.
So we were prepared. Look at that. This, again, we've got to get this between the load and the stretch film. And also, because that cam action is measuring a 4-inch cam, I got to get a 4 inches off here. This becomes a little more, I've got to settle it down. So I've also got to take a tape measure and try to be 12 inches in from this edge. So, and that's to the center point. And look at that, it was pretty close.
Pretty close.
It was about 11 and a half, that's not bad.
Not bad.
I might have taken measurements before once or twice.
Yeah, you know what you're doing.
Done this once or twice. So then we got to put the hook through. And because I have no way of controlling the 4 outside the tape measure that you're going to read for me, we got to pop a little hole in the film next to it. Now I'm just going to, again...
Still going for the 4 inches.
Still 4 inches off. Re-zero my force gauge. Come in. Tell me when I get the 4.
Right there?
And you can see here, I have a 13.13.
Right.
And again, with that first reading that we got with the Landtech was
12.
it was 7. It was 7 points.
Oh, that's right.
We go in the memory look.
Yeah.
That was almost 14.
14.
We're in the margin of error of the 2 devices. But the difficulty of this is with this particular one, it takes a little bit longer because if this was a fully wrapped load, well, now
get it down there.
Now I got to get it to the same point down low, and I'm pulling the stretch film, pulling the stretch film. And again, now we're down low.
Still calculating the same thing. It's just more ease of use is the difference.
Exactly.
There, right?
And that's why we like the Landtech if we can use it, unless, we don't happen to have it with us. If there's 2 of us out, Sean or I are out doing both of these, both doing tests at the same time. One of us will have the Landtech. We normally arm wrestle for it.
Okay.
And then, we'll go over the...
Who wins normally with the arm wrestle?
It usually depends on... It's usually him because he's younger and more fit than me. But, it is what it is. So, welcome to reality, right?
Yeah, age sucks.
Yeah. So, anyway, so we put it on there. Oh, I got to pop your little hole for you. There you go. We re-zero out. And again, we had 6 point something here.
There you go.
And I'm at 8.3.
That was, but
yeah, so we're in the area, same area again, within the margin of what we would consider. That's got on double to 16. It's the variability of the gauges, but it's acceptable. Then once we have that information, we'll go and enter it into the computer, and away we go. And with the calculations, again, we'll calculate the amount of film that you actually used, the cost, potential savings, and everything. But again, one of the big things as we discussed upstairs while we're looking at the load, something to remember, the goal is everything is always to try to down gauge. We may actually want to up gauge. If this was a bottling line with bottles of cola coming off the line.
Refreshing soda.
Yeah, exactly. At high speed, if I'm putting on 12, 16 wraps, if I can up gauge and only put on 7 wraps and still have the same containment force by up gauging, I'm going to go faster, plus potentially save more money because even though it's a heavier gauge of film, I'm using less film. But I'm going to also have the production advantage. I'm going to speed the number of units that can get stretch wrapped per hour. So that can be a win. So then the next step is, and this is where you get into the cut and weigh. Okay, we have our scale. So we turn it on. We always weigh in grams. Okay, let me put it up here and zero. Well, let's put it down a little lower. And we'll zero it out. Then the next step is to take a safety knife and remove the film. And this is where the name cut and weigh comes from. Right. It's the fun part because it's like poppets. Yeah. You know?
Air bubbles.
Squeeze as much air out of it. And then we weigh it in grams. And this particular load weighed 88 grams. So when we change the film out and go to a lighter gauge film, or film we can get more stretch to, something that has a little higher stretchability to it, we're going to end up using less film. The goal would be to have a lesser weight than what their standard production film is.
So let's test the other films.
Okay,
right?
Very good. Let's go ahead. I'll go ahead and get the film changed over, and we'll go from there. All right, so now, Billy, we've gone ahead and rewrapped this with a lighter gauge film.
Okay.
We are about 15 points lower in the gauge. So we're going to go ahead and again place our test fixture here. I don't need it on this one.
Oh, you don't? Okay.
Because it's got the
measurement.
This is why I prefer this one.
Yeah, it makes sense. You don't need me. That's why you prefer it.
Yeah. So I pull it around and I look at the difference. And again here, lighter gauge film. Okay, we were 7 and now we're at 6.5. So still within the acceptable range. When we do the calculations, you'll see we're in the acceptable, which that converts to 13. We were at 14, we're now at 13. It's an acceptable range for test performance for the load containment calculation that we'll do.
What are all of the variables? What were the most important variables for machine film? Is basically the thickness of it, or
there's actually how the film. There's cast and blown films, and depending on how the film is manufactured that way, you have certain characteristics of elasticity of stretch, and that has to do with the orientation of the fiber or of the material at the molecular level. So a lot of films that have very high stretchability. Okay, once they do tear, they have a very linear tear, which means it's going to go and tear straight through. Where the other types of films, they don't have as much stretchability, but it takes much more effort to tear. So what are you looking for? So in a uniform load like we have here, we're fine with going with that high stretch because the typical stretch is either 200 to 300% of what the film is off the roll. We're trying to stretch it to 200 to 300%. And with a more stretchable film, a more linear film, we can get that higher loads on that. But if this was a very irregular load, so you're shipping small
cut that's all
there's different things sticking out, different size boxes. Think the small parcel world. Yeah. Okay, that has a lot of things that can protrude in part. You're going to want to have a film that actually doesn't stretch as much, but it's harder once it does, and if it pokes through, it doesn't tear as much. Yeah. So different characteristics of the film, and that's getting into that's almost a 300 level class type thing. Really getting into the nitty gritty. Most of the time, we don't get that level unless there's a lot of known problems. Typically, you don't quite have to go to that level. But a couple times a year, we're like, okay, we're doing multiple tests and we're looking at that different stretchability of the film. So now we'll go ahead and do the lower one, and you'll see we'll get a little bit of a variance here also. And again, I'm not necessarily using my measurement because I know I've done this enough times that
you're right on it.
Yeah. So now we'll go ahead and zero out. And there we go. We're a little bit less here at 5.1. So again, we're consistent. A thinner gauge film, okay, you're going to have slightly less force retention, but when we do the calculations, we'll find that there'll be a cost savings. We'll still have the needed force to contain the load, and there'll be a cost savings in the material. And that can be depending on the amount, if you're doing quite a bit of pallets, let's say you're doing 10 pallets an hour on a, 16-hour day, that's a lot of pallets. That could be, a good, well into a six-figure
Wow.
number saved.
Huge.
So, yeah, there you go. That's how the testing's done.
That was fun.
Then from there, we'll finish the calculations and make recommendations to the client.
We don't do enough field trips for podcasts, so I've enjoyed this.
Yeah, we should. More field trips are fun. So.
All right, let's head upstairs and talk about the impact of this stuff.
Okay, very good.
That? Thank you,
Sounds
sir.
like fun.
And we're back.
We are back
at the table. Thank you.
I know.
For
coming back upstairs from our
little testing.
Yeah, a little adventure into the warehouse.
So, when we do this, and we can do this for any of our customers, right?
Correct.
Obviously.
Correct.
Are they surprised, or are they? Is it a step in the process that they just don't put that much focus on and don't realize the potential savings there, because they're just kind of, they don't really know about any of this stuff, and they're just kind of, they put a pallet on a machine wrapper and just let it go and don't even think.
For the most part, they are very surprised until our sales team actually brings and starts talking to them. Then there's all of a sudden somebody that starts within the operation and starts to realize, hey, there's potential here, because it is something that we'll use it. It gets lost in the forest.
Yeah.
So yeah, they're very much surprised, and everybody kind of goes, "Huh, are you right?" And we're like, "We'll come back in and do the test again if needed." And it's amazing.
But it creates kind of a light bulb moment, I would imagine.
And that's one of the reasons why when we do the test, we try not to necessarily just test each film once. We want to have on multiple loads to show that it's a repeatable number and repeatable.
So what you want to discuss, maybe just kind of the results, how we come up with those?
Yeah. So, again, we have a calculator. Here I have two examples of two different films that we did out there. This is the heavier film at the beginning, and then this was the very light film that we tested. So if I go ahead and get the grams, it's already zeroed out and in grams. Just like we weighed out there, this one weighs 88 grams. Gotcha. Okay? So now I take the next load and, next film off of it. Touching a little bit. Let's get that. So everything, even so small, is up on the scale. All right, that's at 67. So that's at 67 grams. So all of a sudden now you can see that for the same force retention, which we didn't really talk about that number, but the loads are within acceptable force retention. Again, the calculators will show that. We have this number that we're talking about that was really coming in, we went from 88 to 67. That's a 20%, 25% reduction in the film cost. So in theory, if the cost of each roll was equal, you go to the lighter weight film, you're going to have say a 25% savings in your film cost. And that's a 25% savings in the environmental impact too.
Right.
So it can be a very significant number. So like you just talked about the question you just asked, you're like, wow, it was a bit eye-opening. Never really thought about it because it was just part of the operational tasks that we had to do.
That is awesome and impressive that we can do that for our customers. How many of these do you do in a year?
So we do probably, I will probably say 3 to 4 a month. During peak year, but it always you got to say on average that's 3 or 4 a month, because especially dealing with e-commerce companies. We're not going in and doing these during their busy time of year. Of course, so there seems to be a spike of them, let's say second and third quarter. First quarter, everybody's kind of going, okay, recovering from the previous year. In the fourth quarter, especially if that's your peak time of year, you're just trying to get through peak time of year.
Everybody puts their head down and comes out on the other side.
Correct.
Hopefully.
Correct.
Again, this has been, and I wouldn't have expected anything less from you. This has been very enlightening.
I know.
I appreciate it.
I enlightened a boring topic.
Hey, even boring topics can pay dividends, right?
It is. It's a huge dividend, and we talked about it. We often see customers, if you're wrapping, let's say 8 to 10 loads a day, working 2 shifts, 16-hour days. This gets to be in the potential of low 6-figure savings that you can see each year. Who would not like that?
Why not? Yeah.
Yeah. Why not?
Sign me up.
For an operation For machines that typically tend to run pretty much on their own.
Right.
Well, why not?
Just another amazing way Premier partners with our customers.
Exactly.
So
very good.
Thank you very much, Chuck. Until next time.
Thank you, Billy.
We're going to have to come up with some other obscure little topic that you and I can do 20 minutes on.
We will do that
next time around. I'll be here for
Let's talk banding clips.
There you go. Banding clips. That one might be it's like we'll do a teaser on that.
Oh, there you go. There you go.
Until next time, everybody, this has been Chuck Pomles with Premier Packaging, me, your host, Billy Watkins, for the whole package. Until next time, bye-bye.
Do you have comments, questions, or ideas about this topic? If so, we'd like to hear from you. Please visit primpack.com/podcast to let us know what you think. Thanks.